All right, everybody, we're on lesson number 5 here, page 625. We're going to start proving identities, and we did a little bit of that in the last lesson. We're going to continue it this lesson. The first part here, they're going to talk about restrictions. We're going to skip that. So we're going to go to the bottom of page 626. This bit, hints in proving an identity. So there is no tried and true method for doing this. It's sort of experience, and there's a few guidelines, but you basically just have to try everything that you know. However, a few things that will usually help. Number one, begin with the more complex side. It's easier to take something that is complex and shrink it down than to take something that is small and blow it up. Use reciprocal, quotient, Pythagorean. So basically this is what we talked about before, is if you see a trig function squared, with a plus or a minus 1 or something, it's probably a Pythagorean identity. For example, this is the Pythagorean identity, sine squared plus cos squared is equal to 1, rewritten. Okay? And you will need your formula sheet for doing this unless you've memorized all those formulas. Okay. The other thing is change everything to sine and cosine. Now, this isn't hard and fast, but usually it helps. So if you see any tans, you want to rewrite them as sine over cos. If you see a secant, you want to write it as 1 over cos, etc. Always try to factor. All right. Usually it's a common factor, but sometimes it's the difference of squares. And so, for example, let's look at sine squared x minus 1. This is a difference of squares. This is sine x plus 1, sine x minus 1. Okay? So just be familiar with the factoring. If there is adding and subtracting fractions, combine to make a single fraction. So if you have 1 plus sine x over cos x like that, you want to make it a common denominator and turn it into one fraction. So this would be the 1, because our common denominator is cosine, be cos over cos plus sine over cos, and then you can combine them into, see if I can write it here, cos x plus sine x over cos x. Okay? And remember, cos x plus sine x is not 1. It's only when it's sine squared plus cos squared that you get 1. And the other one that they don't write, but you need to remember, is you don't cross the equal sign. All right? You cannot cross the equal sign. So, best way to do this is to practice. So we're not going to do any verifying. We're not going to do a graphing calculator. We're going to prove it. Okay? And here's what we're proving. Yes, 1 over cos minus cos is equal to sine times tan. Okay? Well, usually it'll have stuff written left side, right side, which divides it right down the middle here. Okay? I'm going to write it over here. So what I usually do is I go 1 over cos x minus cos x is equal to sine x tan x. All right. I draw a line right to the equal sign, and that's what I do. And I want to prove the left side is equal to the right side. So what is the more complex side? I would say it's probably the left side because you have a fraction in it. Okay, 2 terms. Now, if you have 2 terms, one's a fraction, what do you try to do? You try to combine them. So we want to make a common denominator here. So 1 over cos minus, now we have cos x. I need a common denominator of cosine, so I'm multiplying top and bottom by cosine x. So I got 1 minus cos squared x all over cos x. Okay, now, doesn't look anything like what's over on the right-hand side. But what is 1 minus cos squared? Well, if you think about your identity sheet, maybe I should pull that up here. There it is. Here's our Pythagorean identities. Because we have trig function squared with a 1 in it, we have this 1 minus cos squared. So if I move the cos squared over to the other side, how do we get that? That's from the previous lesson. So, all right, this 1 minus cos squared is actually sine squared x over cos x. Now, at this point, if you don't, where it looks like we're getting close, we have a sine, this is a sine and a tan. So we can start messing around with the other side. So we can't move across the equal sign, but you can change both sides. One of the other rules they had up here was if you have a tangent, rewrite it as sine and cosine. Well, why don't we do that? So I have sine x. Instead of writing tan, I'm going to write sine x over cos x. And remember, that is from your formula sheet right there. Okay, tan is sine over cos. So I can multiply these. Sine times sine, sine squared x over cos x. And look at that. We have the same thing. Once you've got the left side equaling the right side at any point, you're done. All right? The left side is equal to the right side. You are done. You walk away. You've proved it. Okay. Let's try the next one. The form we just did. So we're going to go to the bottom here. We have sine x times cos squared x plus sine cubed x is equal to 1 over cosecant. Ugh. All right. So what side is more complex? I would say it's probably the left side. So what can we do? I'm just going to rewrite that here. Sine x plus squared x plus sine cubed x. And this is 1 over cosecant. What can I do? Well, look for factoring. We have no tans, so I can't rewrite anything on the left side, but I can factor a sine out. So if I pull sine x out, I'm left with cos squared x plus, now there's 3 sines. If I pull one out, I get 1. And hopefully that sets off alarm bells. Cos squared plus sine squared on your formula sheet is 1. So this becomes sine x times 1, which obviously is just sine x. You can't go any further than that. It doesn't look the same as the other side, so now we have to mess around with the other side. And remember, we don't want any cosecants. We want everything to be sine and cosine. So what is cosecant? It's 1 over sine. So this is 1 over 1 over sine. Well, you flip the bottom fraction when you're multiplying, or dividing, sorry. That is just sine of x. And we are done. All right. Change everything to sine and cosine. Look for factoring. Do not cross the equal sign. Keep manipulating until you get there. Okay. Now, what about this one? Oh, excuse me. Which side is more complex? I'm hoping you said the left side. Actually, I'm going to erase that line because this one's a bit big. These can get big and complex, but if you follow the rules, you'll be okay. So we have sine A plus tan A, 1 plus cos A. I'm going to prove this. Okay, so let's start with the left side. We have a big fraction, sine plus tan over 1 plus cos A, but we have this tan. We need to get rid of that tan. So I'm going to rewrite it. Sine A plus tan is sine over cos. That's all over 1 plus cos of A. Okay. Well, now, just looking at the numerator, we have fractions. So we want to combine them into one term when you have fractions. So that means I need to make a common denominator, which is going to be cosine. So I want to multiply this one by cosine to get a common denominator. So now the top becomes cos A sine A plus sine A over cos A. That's the top, and the bottom is still 1 plus cos A. Okay. Now what can I do? I don't have any cotans or tans or anything. We're just looking at the left side. We're not touching the right side yet. Okay, so, well, this bit at the very top, I can factor out a sine. So I'm going to pull sine of A out. And I'm left with cos of A plus 1 over cos of A. And that is all over 1 plus cos of A. Let's go up here. So we have a fraction over a fraction, and this 1 plus cos of A, you can think of it as over 1. When you're dividing fractions, you flip the bottom fraction and multiply. So now I have sine of A, cos of A plus 1 over cos of A times 1 over 1 plus cos of A. Okay, I just flipped the bottom fraction. Now, stuff cancels. This cos A plus 1 and 1 plus cos A are the same thing. They cancel. So now I'm left with the 1, doesn't matter, sine A over cos of A, which is what? That's tan of A. I'm going to leave it in both cases because you can't go any further with this. You can either leave it here or you leave it there. So now we're going to look at the left side, which is 1 over cotan A. What's cotan? Cotan is, if you don't remember, in terms of sine and cosine, cos over sine. So I can write this as 1 over cos of A over sine of A. 1 over a fraction means you flip the bottom. So I'm just left with sine A cos A, which is that, or you could just say it is tan A, which is that. And the left side is equal to the right side, and you're done. Okay? So that one involved pretty much every step that we learned. Fractions, factoring, common denominators, flipping when you multiply, etc. Changing everything to sine and cosine. All right. Go down to the bottom here. Last one. Prove that secant squared over secant squared minus 1 is equal to cosecant squared. Okay. Well, what side do you want to start with? I would say we start with the left side. Okay, so secant squared over secant squared minus 1. You cannot, let me be clear about that, you cannot cancel those out, okay, because there's 2 terms in the denominator. So that is a no-go. But hopefully you recognize, now I'm going to show you a couple different ways to do this one. Secant squared, trig function, and a 1. So we look on our formula sheet, secant squared. And there's a 1 plus tan squared. So if I moved over the 1, it would be that. Secant squared minus 1 is equal to tan squared. So I can rewrite this as secant squared of x over tan squared. Oops. Tan squared of x. Now, we don't want sines, or tangents, or secants, or anything. We want everything to be in sine and cosine. So what's secant? That's 1 over cos. So secant squared is 1 over cos squared. Over, what's tan? sine over cos. The tan squared is sine squared over cos squared. Fraction over fraction means you flip the denominator, flip the bottom one. What happens? Cosines cancel, you're left with 1 over sine squared. What's 1 over sine squared? Well, that's secant squared, or cosecant squared, sorry. Or you could have stopped at this point and taken this one and went, well, that's 1 over sine squared, and made them equal. Okay? Doesn't matter at what point you stop. All right? Now there is another way to do it. If you didn't recognize, I'll do it in purple. If you didn't recognize that secant squared minus 1 is tan squared, what you could have done right at the beginning is changed everything to sine and cosine. So secant squared is 1 over cos squared. So I get 1 over cos squared over this bottom bit is 1 over cos squared minus 1. Okay? Top bit is just the secant, and this secant squared is 1 over cos squared minus 1. Now we have a fraction. So I have to make a common denominator. So what I want to do is I want to turn this 1 into cos squared over cos squared. So now I have 1 over cos squared over, I can combine them, 1 minus cos squared over cos squared. And then you would recognize that you can flip this. So it's 1 over cos squared times cos squared over 1 minus cos squared. Cos squareds cancel. So I'm left with 1 over 1 minus cos squared. And then hopefully you recognize that 1 minus cos squared is sine squared. Sum 1 over sine squared, which is that. Okay? It doesn't really matter which way you do it. There's multiple ways to do almost every question. It's totally up to you. But remember, change everything to sine and cos if you're stuck. If you see a trig function squared and a plus or minus 1, think the Pythagorean identity is rewritten. If you have fractions, make a common denominator and put them together. And always remember that you can factor. Okay? It's really just about practice, everyone. So I would like you to do numbers 1, 3, and 4, please. Please practice. It's the only way to get good at this. All right, let me know if you have any questions.